Hello, grade 10 students. I'm teacher Alan Natividad. How are you? I hope everyone is doing well. Today I'm going to discuss with you the lesson sequences. Let's first do the activity 1. Guess the next 3 numbers. Let's start it off. 2, 3, 4, 5. The next 3 numbers are 6, 7, 8. Next. 2, 4, 6, 8. The next 3 numbers are 10, 12, 14. Next. 1, 4, 9, 16. The next 3 numbers are 25, 36, 49. Next. 30, 25, 20. 15, 10, 5 are the next 3 numbers. Next, 3, 6, 12. The next 3 numbers are 24, 48, 96. What you have just seen and heard are sequences. For you to illustrate what a sequence is and to generate some, let us do the second activity, generating sequences. In this activity class, we will be writing the peso bill denominations, the positive multiples of 5, decreasing regions in a square where the first 3 regions are 1/2, 1/4, 1/8, and the first 6 triangular numbers. Let's start it with peso bill denominations. As we all know, peso bill denominations begin with 20 pesos. 50 pesos followed by 100 pesos, 200, 500, and 1,000. How about the positive multiples of 5? We have 5, 10, 15, 20, 25, 30, 35, and so on. About the decreasing regions in a square, we have 1/2, 1/4, 1/8, 1/16, 1/32, and so on. About the first 6 triangular numbers, we have 1, 3, and 6 as the first 3 numbers, followed by 10, 15, 21. These sets of numbers are another examples of sequences. Let's take the sequence of peso bill denominations: 20, 50, 100, 200, 500, 1,000. In this sequence, each member is called a term. A term can be represented by using any small letter of the English alphabet. In this discussion that we are having right now, we will be using A to denote a term. So for the first term, we have A sub 1. Second term can be represented by A sub 2. Third term by A sub 3, and so on. And the nth term by A sub n. What is a sequence now? A sequence is actually the range of a function having its domain the set of positive integers or a subset of it. For you to understand further this lesson, let us answer the following questions. Given the triangular numbers 1, 3, 6, 10, 15, 21, what is the first term or A sub 1 of the triangular numbers? Your answer is 1, and you are correct. Number 2. Given the decreasing regions in a square, what is the fifth term or A sub 5 of the decreasing area of a square? If your answer is 1/32, and you are correct. Next, given the positive multiples of 5, what is A sub 6 or the sixth term of the multiples of 5? If your answer is 30, and you are right. Next, Given the triangular numbers 1, 3, 6, 10, 15, 25, what is a sub n or n term of the triangular numbers if n equals 5? Okay, since n equals 5, then a sub 5 equals 15. This means that the fifth term is 15. These are the sequences we have just generated from peso bill denominations, multiples of 5, decreasing regions in a square, and the first 6 triangular numbers. The question is, can we find the last term of all these sequences? If your answer is no, then you are correct. Another question is, which of these sequences has a definite number of terms? If your answers are 1 and 4, again, you are right. A sequence that has a definite number of terms is called a finite sequence, while a sequence that goes on and on or continues indefinitely is called infinite sequence. This time, we will be considering this 100 chart. 100 chart in the sense that 1 to 100 numbers are on this chart. All you need to do is to generate other sequences from this chart and try to describe each of them. I think we need to proceed. Maybe you have generated 1, 4, 9, 16, 25. And what is 1, 4, 9, 16, 25? How are we going to describe this? Actually, these are the first 5 perfect square numbers. The question is, does the sequence have a pattern? If a sequence has a pattern, then it can also be described as a rule or form. So this sequence can be described by the formula a sub n is equal to n squared. I'd like to emphasize that describing a sequence by using a rule or formula takes a lot of practice. Don't you worry, because this will be discussed in the module comprehensively. Okay, let's proceed. Maybe you have generated 1, 3, 9, 27. And what's the pattern? As you can see, a term is obtained by multiplying 3 to the preceding term. And the rule is a sub n equals 3 raised to n minus 1. Next, you may have also generated 2, 13, 24, 35. What is the pattern? As you can see, the next term is 8 more than any preceding term. So to get the next term, just add 8 to the preceding term. The rule, we have a sub n equals 11n minus 9, or a sub n equals 2 plus 9 times the quantity n minus 1. Next, maybe you also have this kind of sequence 8, 17, 26, 35, or 35, 26, 17, 8. What is the pattern? If it is 8, 17, 26, 35, then the next term is obtained by adding 9 to any preceding term. How about if it is 35, 26, 17, 8? The next term is obtained by subtracting 9 to any or from any preceding term. The rule for 8, 17, 26, 35, we have a sub n equals 9n minus 1 or 8 plus 9 times n minus 1. And for 35, 26, 17, 8, we have the n term is equal to negative 9n plus 44 or a sub n equals 35 plus 9 times the quantity n minus 1. This time, we're going to write the first 4 terms of a sequence defined by the following rule. First rule, we have a sub n equals 2n plus 1. Second rule, a sub n is equal to 5n minus 3. Let's have the solution for the first rule. If n equals 1, then a sub 1 is equal to 2 times the value of n, which is 1, plus 1. Following the order of operations, we have a sub 1 equals 3. If n equals 2, then a sub 2 equals 2 times 2 plus 1, a sub 2 is 5. If n is 3, then a sub 3, 2 times 3 plus 1, the third term is 7. If n is 4, then the fourth term is equal to 2 times 4 plus 1. The fourth term is 9. Hence, the sequence is 3, 5, 7, 9. Let's have the solution for rule number 2. If n is 1, then a sub 1 is equal to 5 times 1, which is the value of n, minus 3. Again, following the order of operations, we have a sub 1 equals 2. Next, if n is 2, then a sub 2 is equal to 5 times 2 minus 3. The second term is 7. If n is 3, then a sub 3 equals 5 times 3 minus 3. Then the third term is 12. If n is 4, then a sub 4 is equal to 5 times 4 minus 3. Then the fourth term is 17. Thus, the sequence is 2, 7, 12, 17. Before we end, let's define the following terms or words. A sequence is a function whose domain is the finite set 1, 2, 3 and up to n, or the infinite set 1, 2, 3 and so on. A finite sequence is a sequence that has a definite number of terms, meaning it has a last term. An infinite sequence is a sequence that goes on or continues indefinitely, meaning it has no last term. That concludes the discussion today. Thank you and have a good day.